Yes, good afternoon to everyone. So today class we are going to discuss about that um, fifth unit in the last title, sample data control system, sample and hold, open loop and closed loop control system. Okay, so in this title we are recollect our yesterday class with some points. Okay, so in this sample the data control system having that four cases. Okay, with the help of the simplification of blocks. Okay, with the help of the simplification of the blocks, we are having that four cases. Okay, the first case having this simply only one block is present with one sampler. So you are having that your transfer function is c of z equal to g of z into r of z. Then in the second case, your transfer function having this c of z equal to g1, g2 of z into r of z. That means only one sampler and two blocks are available in this sample to data control system. So your transfer function like this. Okay. Then in the third case, the blocks are separated with the separate sampler means your transfer function is varied as g1 of z and g2 of z. Okay. So that's a difference between that previous case and this case. Okay. Then in the fourth case, we are having that only one difference, that difference having that one zero order hold system is connected in the blocks. Okay, so that means we are having that simply represented as g naught of s. Okay, so g naught of s is the representation of the block of the zero order hold system. Okay, so these are the four cases sample the data control system. Here we are having that case one, that is the block represents the case one is only one g of s is present. Then you are taking the simplification of this one sampler and one block means you are taking this only g of z. Okay, then your transfer function having this c of z equal to g of z into r of z. Okay, then in the second case the blocks have to be separated with the 2 points. First one is g1 of s, another one is g2 of s. Okay, then your final transfer function having this g1 g2 of z into r of z. Why we not considering this g1 of z? Why? Because only one sampler is there, so the blocks having that common transfer function of z. Okay, common function of z. Okay, so your c of z equal to g1 g2 of z into r of z. Okay, then in the third case we are having that separate sampler with the separate blocks. Okay, the first sampler having that first block, so your transfer function in that z transform we are having that g1 of z. Okay, then here also you are having that separate sampler with the separate blocks g2 of s. Then we are having that simplification of these two means you are having that g2 of z. Okay, then your input signal is r of t is taken as r of z. Okay, that's a third case of the sample and hold system. Okay, then in the fourth case, we are having that zero order hold. Okay, in that zero order hold, only one block is included in the G of S. Okay, then you have to represent the zero order hold system like this G naught of S. Okay, then you are going to simplify this means you have to take only one representation for the G naught of S, which is the 1 minus Z inverse divided by S. Okay, 1 minus z inverse divided by s. This for the is a zero order hold system. Then the remaining part is z transform of g of s. Okay, z transform of g of s. Okay, so these are the four cases in the sample and hold system. Okay, sample the data control system having that four cases we discussed here. Okay, yesterday we collected the same. Here I am recollecting the points. Okay, then we solved that this problem with the two steps. Okay, so that is that problem of sample and hold system with the closed loop control. Okay, with the closed loop control, that is one of the example problem. In this problem, we are having this only one sampler and only one zero order hold system and only one G of S block. Okay, then one feedback path is connected as h of s, then your feedback signal termed as b of t, then error signal termed as e of t, then input signal termed as r of t, then output signal termed as c of t. Okay, here e dash of t represents the error signal after sampling. Okay, after impulse sampling, that means del of t represents the impulse type representation. Okay, impulse type signal representation, call it as del of t. Okay, so here we are going to take that step by step. Here I am going to discuss this problem with the 3 steps. Okay, see, my first step, I am going to replace this uh, only that zero order hold system is replaced by G naught of S. Okay, that is my first step. In this previous block, zero order hold is there. Here I'm mentioning as G naught of S. Okay, so that's my first step difference. Okay, that is my given question is rewritten as zero order hold system, which is equal to G naught of S. That is only one difference. Then I'm redraw that. I'm writing the same as given in the problem. Okay, already informed this E of t is a error signal. Here E dash of t. Okay, E dash of t represents the impulse sampled signal, impulse sampled error signal. Okay, E dash of t. Okay, then it is that B of t, which is the feedback signal. Okay, so now I'm moving to my step number 2. Here I'm going to solve the step number 2 with the 3 steps. Okay, 3 subdivision for my simplification. Okay, so first I'm taking as e dash of t, g naught of s and g of s. Okay, so I'm going to simplify. Simply I'm taking this forward path, g naught of s and g of s. Okay, then I'm going to simplify this into one term, that means is a transform of g naught of s and g of s. Okay, this e dash of t is taken as is a transform, means e of z, then C of t is taken into the form of C of z. I already discussed in yesterday class. How do we take that z transform? First, you are going to take this time domain into the S domain, then S domain into the Z transform. Okay. Then here you are writing as your transfer function of this C of Z. That means output equation C of Z equal to Z transform of G naught of S, G of S into E of Z. Okay, considering this is my first equation. Okay, this is my first equation. So how do we writing here? So C of Z, which is equal to Z transform of G naught of S into G of S with the multiplication of the input signal E of Z. Okay, so that is that forward path we simplified. Then another one part is there. What is that? It is included with your feedback, that means h of s. Okay, included with your feedback. Okay, here we are already taken this block. Simplification is that e dash of t as e of ez. Okay, then b of t is taken into the form of z transforming b of ez. Okay, then that g naught of s, g of s and h of s, these 3 blocks are connected in a cascade form. That means connected in a series form. Okay, so I'm taken as in terms of the multiplication. Okay, so g naught of s I'm taking directly with the multiplication of this transfer function. Okay, see this, I'm going to simplify these 3 blocks into one. Okay, with the part of the z transform representation. Okay, z transform of g naught of s, g of s and h of s. Okay, that is the simplification of the given block diagram. Okay, see this, how we obtain this b of z. Okay, so b of z, which is output equation from the block. So b of z equal to z transform of g naught of s, g of s and h of s into the input signal e of z. Okay, and then you are saying this b of z equal to z transform of b of s. Okay, then b of s is taken from this Laplace transform of b of t. Okay, we discussed already the explanation. How do we take? First, you are converting your time domain into the S domain, then S domain to that Z transform. So that is the mathematical representation here. Okay, then my third part in the diagram. Okay, I simplified that forward path and that feedback path also. Then only one block is there, that is the summing point. Okay, so I'm going to simplify the summing point with the error amplifier. Okay, I'm going to take this equation from the diagram. Okay, that is that output is E of t. Okay, E of t equal to R of t is a positive, then B of t is a minus. Okay, so I am writing as E of t equal to R of t minus B of t. Okay, then what is that? I'm going to write, let me take E dash of t. Okay, so the E dash of t means what is this? E dash of t, which is equal to E of kt. Okay, what is that E of kt? That means the error signal is taken after sampling. Okay, the error signal is taking after sampling. See this? This is your diagram. Here I am considering, I want to take what is E dash of t. Okay, I calculated that E of t equal to R of t minus B of t, but I need to calculate it E dash of t. Okay, this E dash of t is taken from after impulse sampling. Okay, so we considering this after sampling process, we are taken that input signal T is taken as KT. Okay, so we are going to substitute it T equal to KT in the above third equation. Okay, that means the third equation can be written as in terms of substitution of T equal to KT. That means E of KT, which is equal to R of KT minus B of KT. Okay, so why it is taken? Because I need to consider, I need to calculate only that E dash of t in the given question. Okay, I calculated it E of t, but I have to find what is E dash of t. Okay, so we are taking as the t is in the form of the k samples. Okay, t is taking that the k samples. Okay, then I'm taken the substitution of kt as the equation number 4. Okay, then we are going to take, see that explanation. What is E of kt, R of kt, B of kt means all the impulse sampled signal of E of t, R of t and B of t respectively. Okay, if I need to take E of t after sampling means I collected it E of kt. Okay, R of t is taken after sampling means R of kt. Then B of t is taken after sampling means it is that B of kt. Okay, then I'm going to take the Z transform. Okay, that means E of Z. Okay, see this in your previous equation, you are going to take it as Z transform of this equation. E of Z equal to R of Z minus B of Z. Okay, I need that only the R of Z. Okay, so let me change that the right hand side into the left hand side. So the minus B of Z is taken into the plus B of Z. Okay, so let me consider this is the equation number 5. Okay, see this, what is that R of Z? That means Z transform of R of kt, which is that R of Z. Okay, then B of Z means Z transform of B of kt, that is that B of Z. Okay, then we are going to substitute that what is B of Z. Okay, already we collected in the equation number 2. Okay, what is B of Z in that equation number 2? That means Z transform of G naught of S, G of S and H of S. Okay, that is the part we are going into. E of Z also there. Okay, you are going to substitute this equation in the fifth equation. Okay, so we are going to replace that B of Z as Z transform of G naught of S, G of S, H of S into E of Z. Okay, then I am going to take in this equation. Okay, just I am going to take that E of Z as a common. Okay, so here 1 plus Z transform of G naught of S, G of S, H of S into E of Z. That is the common E of Z we are taking. Okay, then we have to find the step number 3 of the, that is that step number 3 represents the closed loop transfer function. Okay, so what is the closed loop transfer function from the diagram means? That is that closed loop transfer function. That means C of Z by R of Z. That means output signal to the input signal. Okay. That means C of t by R of t. So we are taking that Z transform here for finding the transfer function. So we have to find it. What is that closed loop transfer function? C of Z by R of Z. Okay, so already we calculated what is R of Z. Okay, already we calculated what is R of Z. Okay, then we are taking that C of Z from the first equation. Okay, C of Z from the first equation. Okay, just you are substituting. Okay, so C of Z is taken from the first equation and R of Z is taken from your fifth equation. Just you are substituting in that C of Z by R of Z. Okay, is the transform of G naught of S, G of S into E of Z divided by what is that R of Z? 1 plus Z transform of G naught of S, G of S and H of S into E of Z. Okay. So just you are substituting. Okay. Then we are going to simplify this equation, means we collected the answer. Okay. See this, how do we collect it? So in that equation, okay, in this equation, that numerator and denominator having that common term is E of Z. Okay. Then we are taking that E of Z and E of Z we cancel. Okay. Then only the remaining term is a transform of G naught of S, G of S divided by 1 plus is a transform of G naught of S, G of S into H of S. Okay. Then in the next step, we are going to simplify this equation. Okay. Here we are taking this Z transform of this function as well as Z transform of these three blocks. Okay. Here I am writing only G naught into G of Z. Here I am taking these three blocks only with the H of Z. Okay, G naught, G and H of Z. Okay, here we are going to recollect that cases. Okay, here which case we are going to use? Okay, just remember we are having only one sampler with the three blocks. Okay, three blocks here. One sampler means you are going to take only one Z's. Okay, here also we are having two blocks but only one sampler present. Okay, see this. Only one sampler is present to this block. Okay, then only one sampler is present to the feedback loop itself. Okay, so we are taking the final answer as Z naught into Z of Z. Okay, divide by 1 plus Z naught Z G naught G into H of Z. Okay, so why you are taking only one Z means based on the case number 3. Okay, case number 3 or 2. Okay, see this case number 2. Okay, case number 2 we are discussed here as only one sampler is there between the two blocks. Okay, so we are taking Z1 and Z2 of Z into R of Z. Okay, so based on this property, we are simplifying this given block diagrams in this form. Okay, that is the final answer. C of Z by R of Z equal to G naught G of Z by 1 plus G naught G of H of Z. Okay, that is the answer for this. Okay, that is the transfer function of the given question. Okay, so what's my first step? So here I'm going to replacing uh, ZOH, zero order hold is to G naught of S. Okay, first step I'm going to find this what is E of Z and what is C of Z. Okay, that is my first idea I collected. Okay, then second idea I have to take what is R of Z. Okay, so R of Z calculated, then you are substituted, then finally you are going to simplify this answer. Okay, so that is the important property of the sample and hold system. Okay, is this clear with you?